Hey, welcome everyone. My name is Sham Narayan, and I'm a program manager on the OneDrive and SharePoint team here at Microsoft. I'm super excited to walk you through how the SharePoint Online engineering team thinks, architects, and delivers performance in the cloud. Today, I'm going to pop the hood on SharePoint Online and go deep into some of the architectural and engineering investments we've been making, both across the breadth and depth of our service. I hope you like demos because we have quite a few lined up today. And these demos are really intended to walk you through and help you tie some of our architectural investments with everyday experiences you have with the service. Now, I like to think that delivering what I like to call as optimal end user experiences requires two key things. One, you need to start with great product performance. And what I mean by great product performance is that the product itself is engineered to deliver performance in the cloud. With the switch to the cloud over the last few years, there has been shift in patterns in how users use the service, how people collaborate. Distributed collaboration is now the norm. People are accessing and sharing content across geographies. People work with files that are much larger than they used to before. And just the way people commute and access content has changed. We want to make sure that the product itself is engineered with these things in mind. The other thing we want to make sure is users are connecting to our service in the most optimal way so they can take advantage of our offerings. I'm going to get started with the product side first, and then we'll come back to the networking side towards the end of the session. So with that, let's kick into the first demo of the day, which is about Fluid. So Fluid is a new web runtime or framework that Microsoft has developed, which allows you to build high-performing distributed collaborative applications. Let me now jump into my demo machine and show you Fluid in action with SharePoint and OneDrive files. So here I am on my demo machine, logged into a SharePoint document library, and I'm going to be walking you through a Fluid experience on top of SharePoint and OneDrive files. Joining me today is Tree, who is a colleague of mine and is based out of California, and I'm here based out of Seattle, Washington. And we're going to be remotely collaborating on a document that's going over our action items to put together an awesome demo for Ignite this year. Ignite this year is virtual and remote due to the global pandemic, and Fluid is a great piece of technology to collaborate in such situations. Here I'm going to go ahead and open up this document and bring up the canvas so we can start editing it. And Tree and I have already had a meeting where we outlined the top action items we want to go through, which we have captured in the document that you see. And I'm going to go ahead and @mention Tree to come in and start collaborating with me. Behind the scenes, this would have sent Tree a notification, and he should be jumping into the document any minute. And here you see his presence showing up. I can see him in the document, and he's starting to work through his action items. I know we decided that I will be recording the demo, so I'm going to go ahead and @mention myself on that and put a due date. Now, while Tree is working on the table, I'm also going to copy over some of the notes we had taken in the meeting so we can start flushing those things out as well. So here's the cool thing about Fluid. We both are working on the document with near real-time co-authoring that feels natural and fluent. And as you can see, Tree is starting to correct my notes because I know he's a stickler for formatting and spellings. Jokes aside, let me walk you through what's happening behind the scenes over here. So behind the scenes, what we're doing is every keystroke that Tree or me are making is getting sent over to our data center on the East Coast. In this case, this content is stored in a data center in our Virginia data center. And along with that, we're relaying those keystrokes to all authors in the document. So every change Tree or me are making is getting relayed to both of us, all in near real time. So that's the magic of Fluid, all built on top of SharePoint Online that brings together our core networking, storage, and application investments. With that, let me switch back to my slides and walk you through what else we've been up to. So Fluid is just one experience that we've got on SharePoint, but there are multiple ways you can interact with SharePoint Online, be it with Teams or Office on the desktop or on the web using our communication sites or portal. Our goal is to make sure that you have great performance across all these interaction modalities. And to do that, we've been making significant investments across three foundational pillars of storage, networking, and the applications themselves. I'm now going to dive into each of these sections to walk you through the details. Let's start off with networking first. When we think about networking, our belief is that we need to make sure the networking is great all the way from the end user's machine through to our servers on the back end. And to do this, we actually segment the network into three broad areas, starting with the first mile. You can think about the first mile as the data centers, servers, and networking infrastructure Microsoft deploys and operates globally. This is the network segment where we have the most control over and influence over. Stepping out, we have what we call as the middle mile. This is where we have ISPs and network providers connecting into the first mile or connecting into the Microsoft network. And then finally, we have what we call as the last mile, and which is often the most complex, because here we have to deal with end users out in the wild, connecting from enterprise networks, from their home networks in the current situation, and also on the go using mobile devices. So last mile generally has got a lot of challenges in it. So let me walk you through some of the optimizations we've been up to in the first mile. But before I get into the details, I want to set some context with a tough challenge that the engineering team ran up against as part of our optimization process. To set context, SharePoint is a pretty unique service because we have a varied traffic mix showing up on our boxes all the time. We have requests that are for files of varying sizes, for web pages, API calls that third parties build against, and even video streaming. So when you have such a varied mix of traffic all landing on your servers at high volume, it can cause trouble. We noticed that some of our servers under load were dropping packets, or what commonly known as congestion. And this was because we were overflowing our network queues and buffers. Now, to address this, we actually worked with our network providers and network card infrastructure providers to really optimize and tune our network cards. However, we also realized that our traffic pattern is so unique that we needed to go further. So to address this, we actually built a custom network driver that understood SharePoint Online traffic and was able to aggregate packets arriving at our boxes in a way that kept it from overflowing our network queues and lengths. Now we run our service on virtualized infrastructure. Virtualization gives us a lot of benefit from an elasticity and manageability perspective. However, we wanted to make sure all the effort we had put into our physical network infrastructure was fully available to our virtual machines. And for that, we leveraged something called as SRIOV, or single root IO virtualization. And what this actually does is it takes our physical networking infrastructure, or network cards in this case, and presents it directly to the virtual machines, cutting out any of the middlemen. There was no loss in performance. Stepping into Windows and IIS and ASP.NET. So SharePoint Online team partnered closely with our counterparts in the Windows networking team to really experiment and adopt some of the latest and greatest TCP advancements. As an example, we run TCP cubic on our backend. TCP cubic is a congestion control protocol that allows us to take full advantage of the global Microsoft infrastructure that we've built out. We have high bandwidth, low latency networks that are globally deployed, and cubic allows us to really make full use of it. If we have a packet loss, we can recover much quickly on our backbone and allowing us to fully saturate and use our infrastructure. We also, SharePoint runs on IIS and ASP.NET, and it has so for the last few years. Working with the IIS and the ASP.NET team, we landed a bunch of optimizations in that stack. Now, the good news here is a lot of these optimizations have been also made publicly available and available for you to deploy on your servers, either in the cloud or on premises. Finally, in SharePoint, we have instrumented or added telemetry to all our requests coming into the service. And this allows us to really peer down into the low-level networking stack, low-level TCP connection on each request, and really correlate what's happening on the request across the broad network segments. So we're able to tie every request to what happened on the network. This allows us to identify, debug, and address issues, both on our network and also the last mile. Finally, to work with our data center infrastructure. This is making sure our load balancers, our switching gear, our routers, all were optimized for SharePoint Online traffic. So fundamentally, we have optimized the stack all the way across the first mile for SharePoint Online behavior. Switching into the middle mile. The middle mile is unique. So we have this great first mile that we have built up across the globe. Middle mile is where we have ISPs and network providers actually interconnecting into the Microsoft network or peering with the Microsoft network. Here we have dedicated teams at Microsoft who are working with our networking partners globally to ensure that their traffic that's bound for Microsoft gets into the Microsoft network as soon as possible so we can take over it and optimally route it. But before I jump into last mile optimizations, I want to take you back in time and walk you through how users used to connect to SharePoint Online. So if you go provision a SharePoint Online or an Office 365 tenancy, what we do behind the scenes is provision your SharePoint Online tenant across a pair of data centers. And this is generally for availability and redundancy. And then users were required to connect to the data center directly over the internet. So they would traverse their corporate network, go over the internet, and then finally come into the Microsoft network and access their content. And what we noticed in this model was users ended up spending a lot of time on either their corporate network or the internet before getting into the Microsoft network. And generally you run into congestion or low bandwidth situations on the internet that impacted end user experience. And to address that, we've changed the way we route and connect to Microsoft and SharePoint Online. So if you really think about SharePoint Online, it's actually a bunch of data centers, about 50 odd data centers that has been deployed globally. And we wrap all these data centers in what we call as the Microsoft Global Network. The Microsoft Global Network is one of the largest WAN networks on the planet that is fully managed and operated by Microsoft. Now, the wide expanse of this network really allows us to place what we call as edge nodes, known as Azure front door nodes, at the periphery of our networks. You can think about these nodes as the closest piece of Microsoft infrastructure to our end users that allows us to onboard traffic onto the Microsoft network as soon as possible. Now, we have strategically placed these nodes across the globe, allowing us to make sure that we meet our users where they are. What we've also done is these Azure front door nodes and our data centers are also interconnected with high bandwidth, low latency networks. So this is, again, we're already on the first mile that's interconnected. And we can take advantage of all the optimizations I spoke to you about in our first mile. Now, when a user tries to access their content, instead of directly connecting to the data center hosting their content, we actually route the user to the closest Azure front door node using Anycast routing. So we're able to find the closest node using Anycast and route the user to that. And this way we shorten the amount of time the user spends on the internet before they get into the Microsoft network. And once they are on front door node, we're able to proxy that over to the actual data center hosting their content. So let's assume the user is actually collaborating with another user in a different geography, say in Australia. In this case, what would happen is instead of connecting to the data center in North America, the user would be routed to the closest data center hosting Azure front door node, in this case in Australia itself. And once there, we would proxy them back over our backbone to the actual data center hosting content. By this way, again, in cross-geography access patterns, we're shifting the majority of the heavy lifting to happen on the Microsoft network versus the open internet. Now let me switch over to my demo machine and show you this in action. So for this demo, I've actually logged into a virtual machine hosted on Amazon's EC2 infrastructure in Sydney, Australia. This is a networking and performance demo, and we wanted to make sure that we were standing in a neutral place so that we had no unfair advantage from a networking perspective. On the machine, I have two browser windows open side by side. On the left, I'm connected to a SharePoint Online tenant that's hosted in our Chicago data center, and I'm connecting to it over the legacy path or directly over the internet. On the right, I have a different SharePoint Online tenant, which is also hosted out of our Chicago data center, but in this case, I'm actually connecting to it via Azure front door. I'm going to jump into a couple of command prompts and run some ping tests to see the latency we observed from this machine. I'm going to ping the one that we are connecting to directly over the internet. And we see that the average round trip time is about 168 milliseconds as we bounce packets off our North American data center. On the right, this is the one that's routing via Azure front door. And we see that the round trip time is significantly lower at about 2 milliseconds. And this is because the end user is now connecting to the closest front door And in this case, it happens to be in Sydney, Australia. So the last mile between the end user's machine and the Microsoft network is significantly shortened. So what's the impact on end user experience? Why? Because of this routing. I'm going to switch back to my browser. And what I've done is I've uploaded a 540 meg PowerPoint file to both these tenants. They're the same file uploaded to both these tenants. And I'm just going to go ahead and hit download on this to see the experience side by side. I'm going to get the one that's going direct started first, and then come in and kick off the one through Azure front door. So you see this is chugging along. I'm going to switch over and see what's happening to the one routing through Azure front door. And you see the one on the right is significantly faster. Although we started later, we're already done. And this is because what's happened is we've reduced the route between the end user's machine to Microsoft network. In this case, it's about 2 milliseconds, and we're moving or doing the heavy lifting of moving the bytes over the Microsoft backbone. See, all the optimizations we've done in our physical infrastructure, at the protocol layer, and in the core SharePoint Online stack is all taken advantage of. So here you go, full networking improvements impacting end user experiences in SharePoint Online. So that was Azure front door in action, speeding up real user experiences across geographies. Just to summarize, we've made significant investment across the first mile, middle mile, and the last mile to really tune our network connectivity so that we can deliver great experiences for our users. Now, everything we speak about with networking is about moving bits between the user and the service. But what about the bits themselves? And that's where I want to switch gear and talk about our storage infrastructure, which is all about how we store and retrieve data, and also how we interact with this data to build unique experiences. And I'm going to talk about two things here. First, talk about how we physically store and manipulate data, and then how we use this to build experiences that really delight users. I'm going to walk through our physical storage infrastructure optimizations to begin with. And I'm going to walk through how we upload a file into SharePoint Online, and then walk you through some of the backend optimizations we've made to support this at scale. So let's assume here we have Betty uploading a file to SharePoint Online. She sends the file over to SharePoint Online. The first thing we do is we actually take that file and split it into smaller chunks. Each chunk is then uniquely encrypted with a key. Now on the backend, we actually use Azure for our storage as our storage tier. We run our storage infrastructure in an active-active setup, by which I mean we're able to read and write simultaneously across 2 different Azure regions for both redundancy, availability, and performance. Coming back to the file, we take those chunked files and then write them in parallel to both regions. Once we've got acknowledgements from both regions saying we have the file, we then turn around and tell Betty that our file upload has been successfully completed. Now let's assume Betty wants a file back. What happens during a download process? Let me walk you through that. So here I am trying to download a file. What we do is, in this case, SharePoint Online goes to the closest Azure region to its servers and starts downloading those chunks in parallel. Now we run a distributed system with millions and millions of transactions going on at any moment. And we do see transient errors or transient latencies crop up, but we don't want those things to be propagated back to the user. So what we do is we have strict thresholds, especially when it comes to latency. And when we trip up against those, we automatically fire a call to the redundant data center and fetch the content from there. So in this way, we are able to assemble the file without incurring additional latency. We assemble the file and then finally send it back to the user. Now, all of these optimizations are happening behind the scenes and is completely transparent to the user or any applications consuming it. Now, when you really think about these underlying storage optimizations, they are really built for availability, scale, and application level performance. Users, frankly, are not concerned about what's happening underneath the hood. And what they really care about are the files they interact with or the documents they are working on. So let's talk about how we are optimizing and building on our physical infrastructure to provide and enhance day-to-day interactions. So let's say you're working on a PowerPoint document or a PowerPoint slide deck here. You open up PowerPoint and open up the slide deck. Once you're done that, you really don't worry about the file. What you spend your time is interacting with the contents of the file. This could be slides, editing text, adding images, moving images around, adding tables, and really spending our time interacting with the contents of the file rather than the file itself. So we wanted to make sure that we're able to build a storage subsystem that understood this and was able to further optimize and really bring to life experiences that are unique. So I'm going to pick one of these slides on my screen and walk you through how the storage subsystem actually treats it. So let's pick this slide and dive into it. So here I have a slide. And if you really think about it, this slide is actually composed of multiple items. It's got some text on it, and it's got a bunch of images that have been layered in to really form the slide. So humans actually interact with these components. So what we wanted to do from a storage subsystem perspective is actually build enough knowledge into our subsystem where we could dynamically access parts of the document, allowing us to be precise about what we access, what we update or edit. And this is where we are able to use our backend infrastructure on Azure with some smart B-tree logic that allows us dynamic access to contents of the file or specific parts of the file in basically constant time. I want to now switch over to my demo machine and actually show you some of the storage optimizations in real world scenarios. So here I am on my demo machine and I'm logged into my OneDrive for Business web interface. I've uploaded a couple of files, a PowerPoint file and a large bitmap file, both of which I'm syncing down locally to my machine using the OneDrive for Business sync client. I'm going to go ahead and launch Windows Explorer and browse to my locally synced folder. Here I see both those files available on my machine. I'm going to go ahead and open up the bitmap in Paint and make a small edit to it. I'm going to go add a green circle. Yeah. And then fill it in with green. Go ahead and hit save on it. You see the word is written the file out to the local disk, and sync client has already picked up the change and uploaded the changes back up to the server. So this was a 100 meg file that we updated, but the update upload to the server completed in about 1 second. So what happened behind the scenes? So I have Fiddler running here that was capturing some of the interaction between the sync client and the backend server that I wanted to walk you through. So here's the first call that the sync client made out to the server once the file was saved locally. So the sync client has some smarts to calculate the changes to the file. It takes those changes and creates a change signature and presents that back up to the server. The server then compares those changes with what it has on the back end and then returns back exactly the data blocks that are required from the sync client so it can create a consistent copy in the cloud. The sync client then turns around and uploads just those changes back up to the server. So you can see in this case, it's uploaded about 700 kilobytes of data back up to the server versus the entire 100 meg. And this is where differential sync comes in, where the client and the server are playing together to really make sure that the end-to-end scenario is as optimized as possible. So if you're a user who is working with large files, constantly editing them, we would only propagate those changes versus copying those files up and down on every edit, which can be a huge productivity win and also a big saver on network bandwidth. That's differential sync. That was storage in a nutshell. A lot of optimizations both in the physical infrastructure tier and also how we interact with the data itself. Now, while we've spent a lot of time on networking and storage over the last few years, very early in our multi-year performance journey, we realized that we needed to bring the applications along for the ride so that they could take full advantage of our innovations in both in the storage and networking stack. And we did two things here. One, we built new APIs that were what we call as modern APIs that clients such as the browser, Microsoft Teams, or the sync client could take advantage of to build unique client experiences. And what I mean by streaming APIs are the best way to think about them would be is if you're on the internet trying to watch a movie, you don't wait for the entire movie to be downloaded. What happens is you hit play, the movie starts playing, and the content is downloaded progressively as you watch the movie. So we built streaming APIs in SharePoint Online that allows you to do exactly that. Historically, the way download would work is you would go back to the backend, reach out to the blob, start processing it, decrypting it, SSL encrypting it and sending it over the wire. And then we would wait for the entire network transfer to complete. So the end-to-end latency included both the server processing and the network transfer component to it. Now with our streaming APIs, what happens is we start processing the document and in parallel start sending the bits over the network. So in this case, we're able to overlap a lot of the server processing with our network transfer time and significantly reducing the overall duration it takes to send bits down to the client. So these APIs are available for use publicly, also are heavily used by first-party Microsoft applications, such as the Sync client or even our browser user interfaces. The next set of optimizations were in our Office applications. While we built streaming APIs to bring the bits down to the machines faster and have local experiences, with Office, there are different scenarios we are concerned about. We want to make sure file open works great. We want to make sure when you're editing or saving a file, that's as fast as possible. Or if you're co-authoring a document with your colleague, that's buttery smooth. So we wanted to make sure that we were tuning our Office applications by building on top of some of the core infrastructure to build great experiences. To that end, we completely rebuilt our Office web apps from the ground up with performance in mind that takes advantages of our modern APIs. We also brought a lot of those learnings back to our desktop applications so that we have great performance no matter the endpoint. Let me now switch back to my demo machine and show you some of these Office optimizations in real life. So here I am back on my demo machine and in my OneDrive for Business, where I have gone ahead and uploaded a 540 meg PowerPoint document. I'm now going to attempt to open this document in the browser and edit it. So let's go ahead and see how long it takes. Here we go. That took about a couple of seconds for us to open up the document and get into edit mode. I can scroll through, and you can see that as I'm scrolling through, I'm incrementally loading thumbnails. I can click on random slides, and it's going to jump to that slide. So the entire content is there. I can edit any slide I need and jump out if required. So this is where we're able to bring together a lot of the storage networking optimizations along with smart client-side integration to really make sure the end-to-end user scenarios are absolutely delightful. So to summarize, we've gone over the networking, storage, and application optimizations we've made across SharePoint Online and some of our core products that allow us to really provide great product performance. Well, that's one part. The second part is we wanted to make sure that users are connecting to us in the most optimal way so they can take advantage of everything we have on offer. And to walk you through what we've been up to there, I want to recall the 3 network segments we spoke about earlier in the session. Starting with the first mile. This is what Microsoft builds and operates, and we have great control over it. Once traffic enters our network, we can optimally route it to the right backend. Stepping out, we have the middle mile. Here we work with ISPs and network providers to make sure traffic's getting into our network as soon as possible. And finally, we have what we call as the enterprise last mile. These are networks that are built and operated by customers like yourself. In working with several of our customers, we have noticed that there are networking bottlenecks in the enterprise last mile that directly impacts end user experiences. And given these networks are operated by you, we need your help in ensuring that traffic that's bound for Microsoft 365 gets out of your network in the most direct and shortest path as possible to the internet so we can take over that traffic and route it in the most optimal way. And to help you do that, we are surfacing deep networking insights about your connectivity to Microsoft directly in the M365 Admin Center. We're doing 3 things there. 1, we are providing you with a Hawkeye view of how your users are actually connecting to Microsoft. Leveraging telemetry from our first-party applications such as Office, Outlook, OneDrive, or Teams, we're able to correlate that with our backend server telemetry to really stitch together an end-to-end view of how users are actually routing and connecting into our services. We are then able to lean on the learnings from operating a global service, looking at customer issues, and be able to auto-detect issues in your connectivity to Microsoft. And then finally, we're able to turn around and give you targeted recommendations that are specific to your connectivity versus generalized guidance. I'm now going to switch over to my demo machine and walk you through the network connectivity insights in the M365 Admin Center. Here we are in the M365 Admin Center, where we have added a new node under Health called as Network Connectivity, which takes us to an overview page which provides a summarized view of the tenant's connectivity to Microsoft 365. The first thing we see here is a world map, which shows us office locations from where users are accessing the service. We've also color-coded these office locations to indicate performance or network connectivity at each location. Green indicates great performance, and the varying shades of red indicates poor or degraded performance. Now, these office locations are also scaled to reflect the approximate number of users present at each of these office locations. Now, if we switch over to the right of the page, we have what we call as scoring panel, and the scoring panel stays with us as we navigate through different aspects of the portal. Here at the top, we have what we call as your network assessment score. And the network assessment is designed to reflect the quality of your organization's connectivity to Microsoft 365. Today, the assessment is a roll-up of network performance to Exchange Online, SharePoint Online, and Microsoft Teams. The score reflects the network connectivity segment between your end user's machine and the edge of the Microsoft network. In other words, the network segment you have the most control over and can directly influence. Across SharePoint Online, Exchange Online, and Teams, we measure different aspects of the network. For example, for Exchange Online, we measure the latency from the end user's machine out to the edge of the Microsoft network. For SharePoint Online, we measure download speeds. And for Microsoft Teams, we measure varying UDP statistics that are critical to real-time audio, video, and conferencing. Now, by reasoning over these various networking dimensions across these three workloads, we're able to put together or stitch together a fairly accurate assessment of your network connectivity to Microsoft, its performance, and its impact on end users. Now, let's assume that I am an administrator or a tenant administrator for this tenant, and I'm hearing complaints about users in Australia having poor experience with Office 365 or M365. I can come into my world map and zoom in to the APAC region, and I see Melbourne, Australia being called out as an office location, and it's been called out to have poor experience or poor connectivity. As an admin, I can drill in to see what's going on in Melbourne, Australia. So the first thing we see here is a network map, which visualizes how users in Australia or in Melbourne, Australia specifically are connecting to Microsoft. Here we see users are based out of Melbourne, and then we see this line go across the Pacific, and we see the user traffic showing up in North America. So in this case, we are detecting users backhauling over possibly an internal network before their traffic egresses out in North America and then enters the Microsoft network in the Washington area in the United States. Whereas if we zoom back in and actually zoom into Melbourne, Australia, you see that we've called out that there are front door nodes extremely close to the user that's available to onboard traffic onto the Microsoft network. So this is a fairly typical scenario where we see large enterprises backhauling traffic to central egress points before they come out to the internet. And this actually has a detrimental effect on end user experience because of the added latency. Now, if I scroll down, we've also called out a set of insights that administrators can use to better identify, debug, and address networking issues within their organization. And we have two categories of insights called out here. The first one is what we call as recommended actions. Recommended actions are high confidence issues that we have identified that have clear next steps that the customer or administrator can go execute on. We have about 8 to 10 such recommendations that we can detect and bubble up today, and we're continuously working on adding more insights and refine them over time. I'm going to pick one over here as an example, which is SSL break and inspect. So here we have detected that Office 365 traffic, which runs over SSL, is being intercepted by probably a proxy or a device on the customer's network, and it's trying to read through packets. Breaking and inspecting SSL packets results in reliability and latency issues, which have detrimental effect on end user experiences. We have a call out that that you can click through that takes you and provides you more detailed guidance on what problems you may run into, how to address them, and how to leverage some native features that are built into Office 365 to meet your security and compliance requirements. I'm just going to dismiss that and come back. In addition to that, we also have the second case of insights where we've identified problems. We know there is some lingering problem in the customer network, but we don't have exact next steps to go address them. And this is where the administrator would need to work with networking and security experts within the organization to further debug the network and address issues. Finally, one of the most common questions that comes up is like, hey, what should my performance be for a given location? And here's where we have this concept of peer comparison, where we are now able to look at performance of other users or other Office 365 and N365 users around Melbourne and compare you to those. So in this case, we see a distribution of network connectivity around Melbourne, and nearly 50% of customers in Melbourne have great connectivity. And this particular tenant is in the bottom bucket, which indicates that there is probably issues more within the customer's networking rather than broad-brush connectivity to Microsoft 365. I'm just going to switch back to the main page. Now here's the absolute cool thing. Everything I've shown you automatically lights up if you're using Microsoft products such as Office, OneDrive, or Outlook. And we rely on something called as Windows Location Services to detect these Office locations securely with privacy in mind. However, we've also noticed that a lot of customers either don't run machines that are capable of supporting Windows Location Services or have simply turned them off. In those cases, you can go in and add your own Office location using the Add Location button, type in an address, and annotate it with additional information such as your internal LAN ID and egress IP that allows us to uniquely identify these locations and actually go ahead and generate insights for them. So there you go. This is the quick tour, a quick lap around the new Microsoft Connectivity Portal, and I hope you can use this to identify, debug, and address issues within your network. So as we wrap things up, I want to come back to the first slide we started the session off with. I want to recap some of the investments we made across our networking, storage, and applications to really make sure that we're engineering performance into our product and we can deliver these unique experiences in the cloud. Along with that, we're also providing you with tools directly in the M365 Admin Center that allows you to identify, detect, and address networking issues in your network. So let's end with that. Thank you.